Hello, this is the next video in a playlist that I'm calling Integration, and I consider this a useful trig integral, and it's a secant power reduction. And let's jump right in. So let's assume we have the integral of secant to the nth power, and we want to do a integration by parts. So let u equal secant n minus 2. And then du would be, the n minus 2 comes out, subtract 1, and then the derivative of secant is secant times tangent, dx. And let dv be the 2 that we didn't put in here, dx. And then the integral of both sides would be v is equal to tangent of x. And the easiest way to see that is if you take the derivative of tangent, you get secant squared, so the integral must be tangent. So this equals, and this is uv minus duv, and then it equals this piece right here. Now everything comes down, but we're going to replace tangent squared with secant squared minus 1, and then we'll distribute the secant n minus 2, and it becomes this. Then this piece right here will add to the other side to this. So that implies that we get n minus 1 times the integral of secant to the nth is equal to this, what's left over up here. Then we divide everything by n minus 1, and we get this. And this is a power reduction formula for the secant function. And that's it. Now, this next integral, if it's an odd power, you get down to secant raised to the first power, just the integral of secant. And this has I'm going to call it a historic history. And I would go on to Wikipedia and look up the secant function integral or something like that. And the history is that this was one of the outstanding open problems in the mid-17th century. And it was solved in 1668 by a guy named James Gregory. So this was an incredibly tough problem. But once you see the solution, you're like, oh, duh. But really, it was very tough to figure this one out. Considered, in quotes, one of the outstanding open problems. So let's just, what we do is we multiply it by 1. So we multiply and divide by the same quantity. And then we let u equal that quantity. So du would be derivative of secant is secant tangent. Derivative of tangent is secant squared, dx. So then we substitute u in here. And then this dx. Notice that, secant times tangent is this, and then secant squared is this. So this is the numerator. So we get 1 over u, which is, the integral of that is the log of u. Of course, you can only take positive values. Don't forget the plus c. Black pen, red pen would get on to us if we forgot that. Then we substitute back in u into the integral. And this is it. And again, go to Wikipedia and read about this. It's pretty fascinating in my mind. So I'm going to do one more, and that is the secant cubed. So this came about when I was watching a video by Press Tallwalker, and he had a square with sides equal to 1. 1 inch, 1 foot, 1. And you randomly put 2 dots into that square in a totally random process, and what's the distance between those? So what would be the average distance? And if you use the trick he showed in the video, then it sort of becomes straightforward. But if you don't and you start integrating, then it involves the secant cube function, and it really starts to become quite hard. Not impossible, but hard. And so here's the secant cube function using the power reduction formula. So if 3 is n, it's 1 over n minus 1, n minus 2, n minus 2, n minus 1, n minus 2. And that reduces to this. And then we just solved that on the previous page, which is this. All right, well, that's all I have for this video. Hopefully you enjoyed that. I sure did. Please like the video and subscribe so you don't miss the next one. Thanks. Bye.